Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today I will talk about syngas fermentation, which is the assuming that by structure addition to bacteria can enhance bacteria performance to produce ethanol and acetic acid. The work was published in Environmental Science Advances by Professor Venkata Mohan in 14th of July 2023 and was entitled Syngas Fermentation to Internal Gene Expression and Microbial Community Dynamics. The research was made in Indian Institute of Chemical Technology in Hyderabad. And why is so important? Because carbon dioxide emissions are very high and causing greenhouse effects. And they are thinking how to make this, how to solve the problem of global warming by how to utilize this carbon dioxide. Syngas is one of the important part of chemical synthesis of many raw materials as acetic acid, methanol. Fischer Tropsch is initial point of many organic compounds, and syngas nowadays is perfectly made using conventional fuel, especially from coal, but also from natural gas. Syngas can be also obtained by gasification, but it costs much energy still, and is quite pollutable still. So, if we would obtain microbial, we would remove the necessity of large energy required to this heating absorbing. So they decide to check how is in case of microbiome. The microbiome were bacteria from sewage treatment plant located in Hyderabad. To remove particles, sludge was filtered using stainless steel mesh sieve and filtered. Then carbon diffused, so bacteria Richmond was using heat shock similar to what documentation using. But here, not like this. So they heat shock only 80 Celsius for 2 hours. And one shell shock, other is boron, ethanol, sulfuric acid, and acid using phosphoric acid, not sulfuric acid, as usual. The growth media was experimental on the buffer pH 7. No pH 6 because the pH 6 used to be to leading to dark fermentation. Here is not the case obtaining hydrogen, just syngas, carbon dioxide with little carbon because there is decided naturally the obtained hydrogen and carbon dioxide is similar to syngas requirement. So we can use this to make syngas and produce ethanol synthesis, but for industrial performance and use as acetic acid. The performance acetic was pH checking and the 24-hour intervals, and then what using the HPLC was checking a refractive sample by using how much acetic acid and ethanol and different cases as carbon dioxide. Microbial diversity was measured by gradient gelative electrophoresis to analyze the diversity, and free the formal primer were checked to find which bacterial base. So 5 to 3 sequences were checked. And then we have gas fermentation results with nitrogen, carbon dioxide, and hydrocarbonic ion acid. As we see there, we have an experiment that was carried for 7 days, and in case of acetic acid, was checked how was used, and the case was so how check heat shock and acetic acid. So we have here that in case of heat shock, there was acetic acid in similar cases quite stable. And even in beta compounds was much lower acetic acid. So beta was heat shock than beta, or sodium oxide, but sodium oxide much still better. So than beta, so acetic acid, then sodium hydroxide had beta. As a result, we obtained these compounds and was checked general stage. So it comes in carbon dioxide adding metal branch with chrome first formate, then formal THF, methylene, and metal core compounds, and other K branch is carbon dioxide. Carbon dioxide can go to carbonates, so obtaining carbon acetyl carbon monoxide leading to acetate and ethanol. This is the way how it's works, that are to produce acetate or ethanol, and small little ethanol was formed from acetaldehyde. So this is the three compounds from which are formed, and very how it is generated. Generally, the bacteria were mostly from sewage compound occurring with different Clostridium, Raceae, Amyloticum, Putrefacines, and some Anaerococcus and Lactobacillus even. So this mostly bacteria, Clostridium, different types of Clostridium, Acetolerans, Theobutylicum cogensis, and Carbocitermus. But this was the little of that. Mostly were Clostridium bacteria in 70%. So control is containing mostly bacteria, some part of for sewage slides, some slightly was fine only yeast from firmicutes, but when wasn't a sediment. So we have similar phase, and we see that heat treatment. In case of ethanol, was better than beta, but less than acid treatment. But in case of acetic acid, the heat treatment was better from syngas. So from syngas was better treatment with acid, but than acetic. Where in case of beta was only 265 milliliters per day, while in acetic acetic was Besser was 171 only, so much lower than heat shock and acid treatment. In case of ethanol, the ethanol was produced mostly in MESA treatment. So if we want to produce ethanol, chemical treatment would be better. In case of if we want to more produce acetic and hydrogen, then heat treatment and acid treatment is much better. So here we have profiling, how to define different components focus using chemical or acetic by chemical components BESA, so acid is best for ethanol obtaining. For acetic acid obtaining is heat shock, and middle in both cases acetic. So acid was phosphoric acid acid treatment. So thank you very much for listening to me. I hope it's enjoyable. See you next time.